Hi, cool coders. Today we're going to be looking at conditionals. We're specifically going to be looking a lot at Boolean data today and looking at how that affects our programming efforts. So we're going to dive right in and look at first Boolean data types, then we'll get to conditionals later on. Then we'll have a pretty fun challenge for this week. So let's do a quick review of our data types. We've looked at Boolean data already, and that's what we're primarily going to be focused on today, where it can be true or false. We did string data already as well, where we did string concatenations, and we've learned how to assign that to variables. And we looked at two different kinds of numeric data when we talked about mathematical operations. We looked at integer data, which are numbers without a decimal, and we looked at floating point data, which has a decimal associated with it, and we've learned how to do basic mathematical operations on these. Like I said, today we're going to be primarily focused on Boolean data, so let's go and look at a bunch of new operators that we are probably familiar with, but we're going to talk about these in the context of Python programming. So when we talk about Python logical operators or any programming language, we're really talking about some kind of operator that returns true or false. Now, when we talked about these in terms of mathematical operators, we were talking about mathematical operators where we combine numbers and they produce some kind of numerical value. So 2 plus 2 equals 4. The operator in that case is the plus sign. In the case of Boolean operators, we have the idea of logical operators that return true or false. And we're going to be comparing all kinds of things when we talk about these. So the first one is probably the most obvious one, and that is going to be what we call a equals operator or equals to. It's where we take two different values and compare them. So 2 is equal to 2 in this case. So in this right column, I have true conditions that will return true as the value. Now, you can also have false conditions as well, and we'll look at that when we look at some sample code inside of Tony. Now, it's also important to note that when we talk about comparing things in Python or any programming language, there are really two ways to do it. You can do something called an identity comparison. It's where we're looking at two different things and we're saying, are they the same? And we'll get into that later on in future videos, but you can also do what we call a values comparison. That was where you have two different things and we're really looking at the value of those two things to compare those. So everything that we're talking about today is basically going to be values comparison, which is going to be the principal use case for a lot of logical operators. And there are identity comparisons that we can make in later lessons that when that becomes important. But for now, think about this as comparing values. In this case, we can actually do numbers as that are hard-coded into our program, but we can also look at variables as well. And we'll look at some examples of that, but I'm just talking about this in terms of numerical values right now. So equals equals is the one that we use to compare two numbers. Now, this can be a little confusing for people that aren't familiar with programming because we've seen equals, a single equal sign already, and that's used for assigning values to variables. Equals equals, and we see those two together, is going to be used for actually doing comparisons between two different values. So the second one here is the opposite of equals equals, which is not equals. So basically, we are looking at two values and we're saying, are they not equal to one another? So if they're not equal to one another, then that returns true. So that's what we would expect in this case right here, where we say 2 is not equal to 1. Greater than, similar to it, is like we would say is 2 greater than 1, that is going to return true. If I said 2 is greater than 2, that would actually return false because 2 is not greater than 2 is actually equal to 2. Which brings us to our next operator, which is greater than or equals to. Greater than or equals to is using two combinations of greater than and equals to and putting those two together, and it's saying it's either greater than or equals to a specific value. So in this case right here, 1 is greater than or equal to 1, but so is 2. It's either greater than or equal to 1 as well. So that would return true in that case. And then of course, like it, less than. So 1 is less than 2, which would return true. And like the less than or equals to here and greater than or equals to here, we have 1 is less than or equal to 2 and 2 is less than or equal to 2. So let's go over to Tony and take a look at these and let's do some code samples here so we can actually do some comparison and see how these work. We'll look at these last three separately because I want to talk about these independently of these other ones that are a little bit more intuitive than the last three that we're going to be looking at. Okay, I'm here in Tony. Let's do some code here. Let's first start off with equals, and let's do the double equal sign for the first condition that we want to demo here. And we're going to start off with some numbers. So 1 equals 1. That we would expect to return true, and 1 equals 2, we expect that to return false. So that's going to print true, this is going to print false, and let's see what happens. And that's exactly what we get. So nothing controversial there. I think that's pretty straightforward. We've seen equals already, like I said, for assigning values, but we're not assigning values. We're actually doing comparison. So make sure that you note that whenever you're in your code, rather than doing an equals, a single equals for assigning values. So let's do some strings here, and a equals a, and let's do a equals b. And of course, we expect this to be equals, and we don't expect this one to be equal. So this is a true statement. The value of this string is equivalent to the value of that string. The value of this string is not equal to the value of that. So this is a false statement. So let's run that. And that's exactly what we get. We get true for a equals a and false for a equals b. So again, a not so controversial set of commands there. Let's change this up and use not equals. And this is basically just going to reverse what we saw already. Not equals, not equals, not equals, not equals. 1 is not equal to 1. That's a false statement. 1 is not equal to 2. That's a true statement. A is not equal to A. That's a false statement. A is not equal to B. That is a true statement. So we're basically going to get a false true, false true. And that is what we see here. False true, false true. So let's look at this a little bit more in depth. So again, like we said, with the operators that we have here, let's do greater than. Now, this one can be a little bit confusing when we talk about strings. It's not going to be too controversial when we talk about numbers, because this is probably something that's very familiar to folks already. So 1 greater than 1, 1 greater than 2, and A greater than A, and A greater than B. I'm going to add another term in here because I want to show you something here. Let's put in 3, and then let's just simply reverse let's add in another term here, C. So what this is going to do is going to compare 1 and 1. That's 1 is not greater than 1, so that is a false statement. 1 is not greater than 2. That is a false statement as well. 3 is greater than 2, so that is going to return true. Let's look at this one here. We have A is not greater than A. Those are equivalent, so that is going to return false. A is not greater than B. And the results of this are going to be false as well, because when we think about comparing strings, we're really thinking about comparing them in alphabetical order. So in that way, if we were to put these on a number line, A would be before B. So it would be essentially a lower number in that kind of thought than B. So A greater than B is false, but C greater than B would be true, because if we were, let's just put this down here for reference. So A, if B, and C, this is my number line. So if I do this, I would expect this to be more like that. A less than B, and B is less than C. And this is my number line. If we were to do that with numbers, of course, we would have 1, 2, and 3 like that. And you can think about A as being 1, B as being 2, and C as being 3. But in this case, this should evaluate to true then, and these both should evaluate to false. So let's go ahead and run this and see what happens now. So we are doing comparisons over here, just like we thought, false, false, true, which is what we thought here. And here again, false, false, and true. So the analog between numbers and letters down here should give you an idea of how they are compared whenever doing comparing strings. Now, if I was to have more than one kind of character inside of a particular string, it's basically going to compare the first character, and the second character, the second character. So if that's the case, if I did C and CA and CB, this would return false, because it's going to look at the first character here and say, oh, those are equal. Then it's going to go to the second character and say, oh, A is not greater than B, and therefore it's going to return false here. But if I was to do something like this right here, CC is greater than CB, I'm going to get true because the first two characters are equivalent. So it goes to the second character to compare those, and that's going to return true because it comes after B in the alphabet, therefore would be greater than that particular character. So again, looking at more than one character in a string, you start with the first character. If those are equivalent, you go to the second, and so on, just like when you're looking up something in a dictionary. So that's a greater than comparison. So let's take this right here, and let's do a greater than or equals to comparison, and just show you how that can kind of change up some of these results as well, and put these into these particular operations down here. Greater than, equal to, and that is denoted by that character string of characters there, equal, greater than or equal to, and let's run that. But let's first do these in our head. So that's going to be true because 1 is greater than or equal to 2, but this is going to be false because 1 is not greater than or equal to 2. So this one is true, false. 3 is greater than or equal to 2. That is true. This one would be true because A is greater than or equal to A. This one is going to be A is greater than or equal to B. That's a false statement. C is greater than or equal to B. That is a true statement. And this one, CA is greater than or equal to B. That is a false statement. And of course, C or greater than or equal to B, that is a true statement. So let's run this and see how we did in our head. And again, true because they're equal, false because 1 is not greater than or equal to 2, and 3 is greater than 2, so that's for true right here. A is equal to A, so we end up with A greater than or equal to, that's our 1, 2, 3, fourth one. I highlighted the wrong one there, fourth, and so on. So you can see how those work out whenever we look at those in string comparisons as well. So let's take the reverse of this just so that we can say we did it, and that would be our less than operator and our less than or equal to operator. Doing a lot of comparisons here, not to get lost in the weeds, but just so that we can have the code samples to show this. I'm not going to go through these each individually, but just so you can kind of get an idea. False, because that 1 is not less than 1, it's equal. This is going to be true, this is going to be false, and so on. So let's just run that exactly as we saw, just to check it. Greater than, we actually change our code here to be this less than, so we can make sure that we're parsing this correctly in the shell, and so that we know what we're looking at. So again, let's say 1 equals 1, 1's less than 1 is false, 1 is less than 2 is true, 3 is less than 2 is false, and false, true, false, and you get the picture there as well. If I was to do the same thing for this block of code here with less than or equal to, if I was to put this less than or equal to, we just simply flip the greater than operator to less than, and we're going to get the reverse of the results that we just saw up above when we did equal to operations, except for where it was equivalent. So in this case, again, still true. This is going to be true. This is going to be false. So we would expect that to be the case. Again, here, true. Here we're going to see true, and this one we're going to see false. And just run that for good measure. Again, true, true, false. True, true, and false. So again, nothing too controversial there. The trick here is just to remember that when you're doing string comparison with greater than or less than operators, it's going to be basically doing it based on alphabetical order, and case does matter here too. So alphabetical order is important whenever you're doing string comparison. Just remember A is functionally equivalent to something lower in the number line than the next one in the list, which would be B and C and so on moving forward. So again, very simple concept, but it's a little bit odd when you start comparing strings for folks that are kind of new to programming. But basically remember, alphabetical order is the key there. So let's look at the last 3 operators that we have here. These are the 3 that we have on our screen. These are OR and not. Now, or and not are used for comparing booleans to one another. The other operators that we looked at were useful for comparing things like values of strings and the values of numbers together. Here we're actually comparing booleans together. So that's why I have over here in my true conditions column right here, where everything in this would return to true, I have these in the midst, I have or in the middle of two other logical operations. So I have one less than two and one equals to 2. So for this one to evaluate to true, at least one of these has to be true. So 1 less than 2 is a true statement. 1 equals to 2 is false. But when I combine those, I'm basically looking for, is this one true or is this one true? If at least one of them is true, the whole thing returns true. However, if neither one of them are true, it returns false. So this one is a little bit more what we might say permissive in what it will allow for in the evaluation of true, and is a little bit less permissive. So if I want to do an and comparison, I'm basically making sure that everything in my comparison is true. So it checks to make sure that this is true and this is true. So in this case, I have 1 less than 2, which is true, and I have 1 equals to 1, which is true. So in that case, with and, the whole thing returns true. However, if one of these is false, so if I said 1 is less than 1, that would return false. The whole thing would return false, even if the other condition that I'm comparing it to is true. Not, on the other hand, basically is used to negate something that's already been evaluated. So it's very useful for evaluating something and then flipping the Boolean value that it returns. So in the case of not right here, I have something right here. I have 1 equals to 2. That is a false statement. And then I take parentheses and put it around that. And then I negate the whole thing and flip it over to true. So not equals to 1 equals 2 is false, then I not that, it becomes true. That's essentially what we have here with this comparison here. But in this case, I'm just doing it in 2 steps. So you can see how these are taking Boolean evaluations and then comparing them to one another to change the output slightly depending on whether I'm using ands, ors, and nots. There's other types of operations that we could talk about, but they're not used a lot, and I'm not going to mention them in this particular lesson, but they are more advanced. But the lion's share of what you're going to be doing in code when it comes to ands and ors is going to use ors and ands, and these are probably used 99.9% of the time, and occasionally you might use one of the more esoteric cases. I'm not going to get into what those are, but in any case, I just want to make you aware of the fact that there are other comparisons that exist. This is not an exhaustive list, but in any case, let's go back to Tony and look at these in action. So I'm here in my IDE, and let's put some print stuff on the screen here. Let's do 1 equals 1 for a starter. That's a true statement. And let's OR that to another statement that isn't true. 1 equals 2. Now, when we run this right here, this is going to return true. This is going to return false. But because this one is true right here, the whole thing will evaluate to true. And that is the conditions in which a OR evaluation would come back as true. As long as one of them is true, the whole thing returns true. So let's run that and see what happens. And that's exactly what we get. So if we were to change this to, say, 2 equals 2, even if both of them are true, basically what the compiler or the execution is going to do is going to see this, oh, 1 equals 1, that's a true statement. It's not even really going to go to the second one. It's just going to see the first one is true, and then it's going to return true for the whole thing because of the conditions in which ORs would return true. So even if the second one is true, the first one is true as well. So it just kind of really skips it in the actual execution of the code. But we know that this would return true based on what we know about the OR operator. Now, the only instance in which OR would return false would be when nothing is true. So let's return 2 false statements here. And so this is not equal to 2. So that is going to be false, and this is false as well. So because neither one of them are true, the whole thing is going to evaluate to false. So let's take this same code here, and let's change the operator here from or to and let's see how that affects things. So with and, what we have here is we have a true statement and we have a false statement. So what happens here is, in that case, because one of those is false, the whole thing gets evaluated to false. So for a true and to be the case, we need everything to return true. So in this one right here, we get 1 equals 1, or 1 equals 1 and 2 equals 2. Both of those are true, so the whole thing returns true. And then down here, because they're both false, we would expect the whole thing to return false. So let's run that and see what happens. So that's what we got. We have the first one, because one of them is false, the whole thing evaluates to false. Here, everything is true, so the whole thing evaluates to true. And here, everything is false, so the whole thing evaluates to false. So that's the output, what we would expect from a condition using ands and ors. Now, with a not operator, we simply can just flip something around. So let's do a not here. And not 1 equals 1. And what that's going to return is false, because the output of this right here, the operation that we saw already, 1 equals 1 is true, and it flips it. So instead of true, it's going to go to false right here. And likewise, if I have something that is false and I flip it, it's going to return true. So it simply just negates whatever is already being returned. So this returns false, it flips it, and then therefore it is true. So let's run that and see what happens. So we have false for the first one right there, and then we have true for our second one down there. So again, we see how and or work, and we see how the not function works as well. And in this case, these kinds of operators are useful inside of programming when you're comparing booleans to one another. Now, in the most of the time, you're going to be using ands and ors, and lesser degree nots. There are some other logical operators that I have not talked about, and they're used rarely. You're probably going to use these probably 99% of the time because these are the principal ones that you're going to use in code. There's other ones out there. I'm not going to get into those for the sake of simplicity because they aren't used that often. I just wanted to let you know that there are some additional operators that you might see in code out there, but for our purposes, we're just looking at these right here and then the not operator as well. So let's go back to the deck and look at how we can sign Boolean operations to variables and then use variables inside of our evaluations as well. Because Booleans are a data type, you can assign the outputs of logical operators to variables. And we've seen how to do this with mathematical operators where we did things like addition, subtraction, and multiplication. That's not too controversial, and with string concatenation. And you can do the same thing with Boolean. So you can take a variable and you can take a logical operator and you can take the output of that logical operator and assign it to a variable. So in the case that we have here, we have x equals the output from 1 equals 2. So in that case, x would be false. And the case of this one where we have x equals, and in parentheses we have 1 equals 1, that would return true, so x would be true. And in the case of less than, we would have false in this case, and then 1 less than or equal to 1, that would make x true. So again, very simple to assign values to Booleans, and then you can take that Boolean variable and use it just like we were using the terms that we were hard coding into our code. So let's go back to Tony and take a look at how you can use variables with Boolean data as well. Now that we've looked at Boolean data, let's apply the Boolean data using some conditions in our code. Now, with conditions in our code, we can use if statements to create conditional blocks of code that execute if certain conditions in an if statement are evaluated. This is one of those things that's better seen than talked about, so we'll get to an example here in a second, but I wanted to introduce the idea of an if statement first. The if statement is basically a statement that says if a condition is met, some condition is true, then execute some code. If it's false, skip it. And then you can have a lot of these chained together using else ifs, or that's evaluated as elif inside of Python. It's shortened to elif. So if the first condition fails, it can go to the second condition, try to match it against the else if. And if that doesn't work, you can have a catch-all that's called else. And an else will essentially pick up if all the prior ifs or else ifs fail. With an if statement, you really only have to have an if defined in the block. The else if and the else are optional. So you can have an if standalone, you can have an if with an else if, you can have if with an else, or you can have an if with an else if and an else. And we'll look at some examples of these when we go to Tony, but this is one of those things, again, is better seen than actually explained here. But I want to introduce the concepts and kind of what they are for the purposes of understanding. So let's go look at the next slide where we'll see an example of this. When we talk about if-else blocks inside of any programming language, we generally need to introduce the idea of a code block. Now, up to now, we haven't talked about this because everything that we have has just been in sequence as we saw it in the IDE. But with a code block, we have to use indentation to tell Python that we want to create a code block. Now, code blocks will be interpreted differently depending on how they're constructed in the code. Now, with if-else, which is the primary one that we're going to be concerned with today, we will start each line of code with some kind of statement, and then we'll end it with a colon. So let's set a variable, which we've seen many other times before, and then we will have an if statement. So we would say if x equals 1. So that is a logical expression where we're using a logical operator equals to evaluate some kind of Boolean operation that will return a value as true or false. And if that statement is true, then the program will step into the code that falls underneath that particular line, and it will be indented. And that is how we define a code block, is with a colon. Then everything that we want to be inside of that code block will have indentation. And I've highlighted the indentation here in yellow. And then when I want to exit the code block or end the code block, I simply go back to unindented code, like we see here with this elif. So in this case, if I said x equals 1, then it would evaluate that first line of code in the if block there. If x equals 1, it would then enter into that code block and execute these two lines of code that we see right here with the highlighted text. So we'd execute those two lines of code. And then it would exit. It would not attempt to go down to the next line, else if here. It would simply execute this and then jump out. However, if x was some other value, say x equals 2, it would skip over this block of code right here and then simply go into this block of code, which we have 2 lines of code in right here. And then if x was some other value than 1 or 2, we can have an else statement that looks like this, and it's a catch-all, and that catch-all would then have a code block associated with it. And then once I want to end my code block, I simply just return to normal indentation like I have with this right here, and then this else as well. So that is how we would handle a code block inside of Python, is using indentation. So let's go over to Python and Tony and build this out, and then let's walk through the code so you can get a better idea of exactly what we're trying to do with a code block, because this is a new concept and it will have a profound implication on your future programming, because you will need to create branches in your code to handle different kinds of conditions depending on what those are. So let's go over to Tony and see it in action. Okay, I'm here inside of Tony and I want to create an if-else demo. So basically what I'm going to do here is get some input. Now I want you to pay close attention to what I'm doing here, because this is one of the most fundamental things in programming that you'll ever do, is creating conditions, because it's used a lot in code. So if x is some value, I want to handle that. So I'm going to first start off with an input. So if I want the user to put some value in, so enter A, B, or C. That's the values I'm expecting the user to enter. And let's close that up. So this is going to be some string value, A, B, or C. So I'm going to handle the first one. So if x logical operator equals A, and I want to do a capital A, I'm going to do a colon. Notice what Tony does for me. It indents the next line automatically because it detected that I'm using if statement with a colon. Therefore, that is a code block, and it therefore needs to be indented so that I can do that accordingly. So I'm going to do some kind of code here. Print A is for awesome. And then I'm going to do another line here. Let's just say print you are awesome. And need my opening quote here. And let's go ahead and run this and see what happens. So first thing I'm going to do is enter A, B, or C, and it's going to go into this value right here, going to evaluate that to true, and then it's going to print these two statements. So let's put in a breakpoint right there on if, and let's run this in the debugger and see what happens. So I'm going to enter a value for A, and it's going to break on that line, and I'm going to step into. Notice over here my variable says X is A, and therefore that's going to evaluate to true, and it's going into this code block that is indented here, and it's going to execute both those lines of code and then exit. So you can see there I have a condition to handle the A value. So let's do an elif now, which is else if. So let's do X equals B here, capital B. And I want to do print B is for BAU to full. Beautiful. I'm only going to have one line of code in this block. Let's just leave it like that for now. And that's because a code block can have one or more lines of code. You could put 10, 15, 20. It doesn't really matter. As long as there's an indentation, it will interpret this as a code block. And then this code block will have a single line of code in it. So let's run this and see how this one works. So I'm going to, oh, I have an invalid syntax. I forgot my colon. So I need to make sure that I have my colon in there before I do something. Sometimes even I make mistakes with syntax. So let's run the first one, A, and that's going to run as expected. It's going to go into our first block, code block there, and then it's going to skip the second one. It didn't even go into this print B is for beautiful. So let's run that again. In this case, let's put in B. So the first thing it's going to do is go to our breakpoint. It's going to evaluate this line of code and see if X is equal to A, and that's going to evaluate to false. Then it's going to come down here to our elif, and it's going to see that X does equal B, and then it's going to execute B is for beautiful. And then our program is done. So you can see here I have an X and if with elif. Elifs are optional. Again, they are determined by the need of your program, so you don't have to have an elif in an else block. However, you do at least need to have a if statement somewhere. So let's add the last value here. C is for cool, and let's have a code block to handle that case, and let's debug that just to make sure that we are going along here. C, and it's going to do exactly as we expect. Skip X equals A, skip over X equals B, and then elif, it's going to evaluate that to C as true, and then it's going to print the C is for cool statement there. And then our program is done. Now let's create a catch-all, and that's where the else comes in. So let's do else here. And with this one, I'm going to have else, and I'm just going to have a colon after it to denote a code block. So let's do a nastygram here where I say, you did not enter in A, B, or C. And this is our catch-all. So if I enter in some value for X, let's say D, it's going to attempt to evaluate all of these conditions, X equals A, B, and C, and those are all going to go to false. Then it's going to hit the catch-all, the else, and it's simply going to print the nastygram to the screen here, be saying, you did not enter A, B, or C, which is what we would expect because none of the conditions were met for any of our ifs or else if blocks here. So you can see here I have a condition where I have an if, an elif, and an else, and we saw if by itself and if with a single elif. Let's do a condition where I have a value where I have something that is just if with else without any else ifs in it. So let's do a if, let's get some more input here. Let's do y equals input, enter a number. Let's do enter a number less than 20. And I'm expecting the user to enter a number, let's say enter whatever it might be, a number less than 20. And let's create an if to handle this. So if y is less than 20, that's our logical operator less than right there, I'm going to say do something, print good job. However, else, catch all, if they don't enter something less than 20, I'm going to say you can't follow simple instructions. So let's run this and see what happens. I'm going to put the breakpoint right here on the second if, and let's remove this breakpoint and debug. So, oh, I forgot my colon again. Look at that. I'm even getting a little bit ahead of myself by syntax errors by not putting inside my colon to indicate the need for a code block. So let's enter in A, just so A is for awesome, you are awesome, and let's enter in 12 for the value. And notice it breaks on this line of code and it says, is y less than 20? My value is 12 over here, my variables, and it says, good job. And it prints that out. So let's run this program again and be a little nutty here. And let's enter in some df for my other value. You did not enter A, B, or C. Enter a value less than 100. I'm going to enter 1,000. And it says my breakpoint here is y less than 1,000. No, or less than 20. No, it's 1,000. And it's going to go, you can't follow simple instructions. So that is an example where I have some numeric data here where I am testing it using less than, or you could use greater than or whatever inside of your conditions here. Now I want to show you one more thing, and that's where you can nest code blocks inside of code blocks. So let's do an example of this. So let's do z equals input, enter A or B. And then let's do another input. Let's do another variable. Let's call it Q. Input. Enter, let's see, X or Y. And I want the user to enter in A or B or X or Y. So what I'm doing here is I'm actually doing some inputs here, and I'm going to move these around a little bit where I have some inputs that I want to show you here inside of nested code blocks. So I'm going to put some ifs around this second input right here. So let's start like this. If z equals A, now here's what I'm going to do. I'm going to then ask the user to input another variable inside of my code block here. So Q equals some value. And then I'm going to say a nested block, code block inside of the one that I'm inside of already. So if Q equals X, let's say, notice what it's doing now. I've got a new code block that's inside of this code block. Here's one code block right here. And then I'm getting a new code block inside of that code block. If Q equals X, say Q is X. And let's print that out. And let's back that up and let's do an else, elif, say, let's say, I don't know, if Q equals capital Y, new code block. Notice what I have here, a nested code block inside of this other code block again, and says print y. I say q is y here. So here I have a code block that starts right here, and it's got 1, 2, 3, 4, 5 different lines of code inside of that code block already. And it's basically the second embedded code block starts right here, and I've got an embedded code block inside of this one right here. So this is a condition inside of a condition, and this is a common thing that you'll see in code as well, where you have nested conditions in other conditions, or where you have nested code blocks in other code blocks. And we're going to look at some other kinds of examples of code blocks in future lessons, but for now focus in on just nesting some of these inside of these various kinds of if blocks that we have here. So let's create a condition for the else here. So let's just do an else, and I really just want to handle some other code. Let's say B right here, else, and just print some value. You entered B or something else like that. And that is just going to tell the user that they entered in something else. I'm not going to ask them for that additional data like I did here, where I have this nested if statement inside of this other if statement. So let's run this and see what happens. I'm going to put the breakpoint right here. So let's go like this, debug it. And the programs I keep forgetting my stinking colon. I do that quite a bit. And it's going to ask me for the first one, A, and that's the first input I asked. As in a number less than 20, let's enter 12. Now I am on the first breakpoint that I have here, and I want to continue resuming this program. And it's going to then ask me to enter A or B. So I'm on this line of code right here, So I'm going to enter in the value for Z here, A. And now I'm at the breakpoint where I'm going to evaluate Z. So let's step into this and see what happens. So because Z is true, I want to enter in a value for Q. So let's step over that, and it should prompt me for enter X or Y. I'm going to enter in X, and then it's going to continue on executing my code here. It's going to say, is Q X or is Q Y? And that's going to be nested. So naturally, it's going to go into that nested code block underneath this code block right here. So this program is getting a little bit complicated. And then it got to this line of code and simply exited because it didn't meet the elif and it didn't go to else. So it's just done executing. So let's run that one more time just so we can see what happens here. And let's run A, and let's put in 12 and get past those first few lines of code. And then let's put it in A again. And there we are at our condition for evaluating Z. And it's going to ask us to enter for Q. I'm going to put in Y for Q. And it's going to evaluate the first, is Q equal to X? And that's false. Q is equal to Y. And so it's going to print out Q is Y, which we expect because I entered in A, and then it evaluated this one for Y, and so got this right here. Now let's enter in some value other than A or B, really. Let's just enter in some other value, say B, and then we can see that this will simply skip over this input and this nested if statement whenever I run it. And let's put in B now. And let's run that. Okay, so I'm going to skip over A. Oops. Skip over A, and it's going to go right down to my catch-all, my else, and say print you entered B or something else. And it's going to exit my program now. Now, notice it did not go to this input here. It did not evaluate any of this code that was nested inside of the code block here. But if I do get into this, I do get the input here. I can skip over this nested code block and go into this code block, for instance. So you can have, in this instance, code blocks within code blocks, if statements within other if statements. So this is an example of nested code, which is common inside of programs. Now, you don't want to get too crazy with this. Again, it can get rather confusing the more you do this, but the idea is that with code is you can have complex branching inside of your code that will result in different behavior depending on how your code is structured. So this is an example of what we're doing in our challenge. So I want to talk about our challenge, and then I'm going to show you my example because I want you to do something like this. So let's go to the challenge, and then we can discuss what that's going to look like, and then I'll show you my example. So for this week, I want you to do something that's kind of fun. It's a game, essentially a text adventure. It's a kind of game where you display a scenario on the screen and then you ask the user to make a choice. So imagine something like this. I'm in a room. There's a door to the north, there's a door to the south. Press N to exit the north door, press S to exit the south door, and then the user would press some key, say N. Then you would display a scenario based on the outcome of that choice. So you exit the north door. There is a car, you need to go to the store. There's also a bike. Do you take the car or do you take the bike? Press C for car, press B for bike. And then you would ask the user to press one of those keys, and then you would display the next scenario based on that outcome. So you can see how that branching can get pretty complex. So what I basically want you to do is create a text adventure that basically will display an initial scenario that asks the user to make a choice. It can be at least two. You could have more if you want. You could be creative with it. I mean, so as you're in a room or something like that, create something that's fun, make me laugh, and give me a little bit of humor. And then have the user input a choice, and then have the display of that choice take me to a new scenario, and then ask the user to make some kind of decision based on that secondary scenario, and then finally show the outcome of that secondary scenario. So let's go look at my example so that you can see what I'm talking about, and then you can use that kind of as an idea of what I'm looking for in the challenge. Okay, I have my example pulled up here. It's called Code in Space, and I've pulled it up so you can't see what I'm doing. I'm simply going to run it, and this is what we have. A long time ago in a computer far away, there was a program running that wanted to explore the universe. It wasn't sure if it wanted to go to a star or planet. Should it go to a star or planet? I'm going to say S for star. The program went to the star and found it was made of bits, but he wanted bytes. The star told the program to go find bytes on Mars. Or should he stay 4 bits? So let's go 4 bytes. The program decided to leave for bytes. He came to a planet of bytes and he bit into the bytes. He loved them and was happy. The end. So let's run that one more time. Instead of going to a star, let's go to a planet. Long time ago in a computer far, far away, there was a program running that wanted to explore the universe. It wasn't sure if it wanted to go to a planet or a star. Should it go to a planet or a star? Let's go to a planet. The planet went to a planet and found nothing but vanilla. He wanted chocolate. Should the planet stay for chocolate? The planet said chocolate is in the Milky Way. Should he stay for vanilla or should he leave for chocolate? Let's go leave for chocolate. The program went to the chocolate planet in the Milky Way and enjoyed cookies with milk. Every bite was delicious. The end. So this is again a cheesy example of how you can create a text adventure using if-else blocks, using nested blocks inside of more parent blocks. So this is a fun way to explore that. So create a challenge and then submit this to me, and you'll be entered into winning a $10 gift card, as well as a chance to make me laugh. And of course, I'll give you a shout out if you finish this as well. So again, looking forward to your submissions and looking forward to seeing you on future lessons with Cool Enough to Code. If you like this content, please consider liking this video, then clicking on the subscribe button to subscribe to our channel, then clicking on the bell notification icon and selecting all so that you'll get notifications when new content becomes available on our channel. You can also click on the share icon and share this video to any of your social media platforms. Sharing this helps make it more widely available for those who might be interested in coding. Also, consider following us on Twitter so you can see updates on Twitter whenever new content becomes available, as well as other announcements related to Cool Enough to Code. You can also help us out by becoming a patron of On Our Page by going to our Patreon page at patreon.com/coolenoughtocode and then clicking on Become a Patron. And there you can find out more information about how you can support our work with Cool Enough to Code. And like always, you can check us out online at coolenoughToCode.com. There you can find a schedule of all of the upcoming lessons that we have. You can also find out more information and reach out to us online here. And you can also watch the live stream as it comes out each week on coolenoughToCode.com as well. And like always, thanks for watching this lesson on Cool Enough to Code.